Right? So, hello everyone. Welcome to a student project at Cheenta.com. I have with me Gurnoor Kaur today. Gurnoor is a student of Cheenta right now. She is taking the Mathematics Olympiad program. Is that correct, Gurnoor?
Yes, sir.
Okay. So, you are in which grade? Tell me a little bit about yourself.
I'm in grade 9 and I am in the Math Olympiad program at Cheenta.
Okay. So, how long are you working on this sort of mathematics?
Um, it's been a year or two almost a year that I'm with Cheenta. Yeah.
So tell us a little bit about your journey into mathematics. Like, what books do you like? Are there any favorites that you have worked on?
Yeah, I mean, to be honest, in the beginning, I really used to not like math. Like, I used to hate math. I was like, I'll do anything except math.
Okay.
But then slowly, as I started to do it, I fell in love with the subject, and now it's like my favorite subject. And there are a lot of books. I see your videos that you recommend, the books that you recommend, and
Okay.
I am currently working with the book Challenge and Thrill of Pre-College Mathematics. I feel like
Okay,
that book.
that's very nice. That's a very good book. It has some really nice, challenging problems on geometry. So I hope you are having some fun with it. Um, so, Gurnoor, I think you're also part of the Maths Circle project. Is that correct?
Yes, yeah.
So, tell me a little bit about that Maths Circle thing, which is, of course, separate from the Math Olympiad program that you're taking.
Yeah, so I'm a leader in the Math Circle program. So I take classes for the SSN students from the school, and
So,
I teach them.
Swapnapur on the school in Sundarbans, right?
Yeah.
Okay, so those of you who are watching right now, I'll just quickly explain what's going on. So many Chinta students actually teach other kids. They have weekly classes, and these other kids are usually from rural schools. Sometimes they are internal students at Chinta as well. What we have seen that it's a very enjoyable experience, especially for the kids, because they get to share their knowledge, and that's a very motivating thing. And when you share your knowledge with someone else, especially from a very different part of the country, it becomes a very enjoyable experience, a very good learning experience. So Gurnoor is a group leader in that as well. So tell us a little bit about this translation project that you have done, Gurnoor.
Yeah, so this was like my first time doing this, and I was introduced to this really great resource website where I can find different resources on different topics in math and as well as physics. But I translated this geometric inequalities resource. I did use Google Translate, but then sometimes I did have to kind of put in my knowledge to understand, because sometimes it's not always what is actually the author has written when you
Yeah,
translate.
it doesn't give you the exact translation. You always have to work on the whatever they gave you, right? So this is very interesting, geometric inequalities. So let's get started with this presentation. So tell us about geometric inequalities and the translation that you have done.
Yeah, so basically, this was a three-page paper on geometric inequalities, which was really interesting, and it did have a lot of interesting problems that I really got to solve, and it was nice. And so, basically, what we'll be discussing is the triangular inequality, and we'll be doing an application problem, like the basic application problem, and just talk about some things that the author recommends doing when you face such kind of problems, and just doing another problem related to the triangular inequality.
Okay.
So to begin off, I think we all most of us are familiar with the triangular inequality, but the most basic form of the triangular inequality states that the side of a triangle is less than the sum of its two other sides. This can also be said in a way that the sum of any two sides of a triangle is always greater than the third side. And
Right.
there's also another form of this triangle. Like you can see, there's a triangle inequality shown here, which of the triangle A, B, and C, ABC. So here, the triangle inequality is that AC is less than AB plus BC, and so when we subtract BC from both the sides of this inequality, we get AC minus BC is less than AB, which states that the difference of any two sides of a triangle is always less than the third side, or you can say any side of a triangle is always greater than the difference of the two other sides of the triangle.
Right.
So this is basically what the triangular inequality is and the different forms that you can talk.
Okay. Yeah.
And so one application problem
So
which
this is from the paper that you have translated.
yes,
Okay.
yeah.
Okay.
So this problem says that prove that the sum of the distances from any point lying inside the triangle to its vertices is greater than half the perimeter of the triangle. So we have a triangle ABC here, and we took a point O, any point O inside the triangle, and so we join this point O with all the vertices of the triangle, forming three new triangles with which we can apply the triangular inequality to solve this problem. So here we have three triangles, AOB, BOC, and AOC. And so applying the triangular inequality, we get AO plus BO is greater than AB, BO plus OC is greater than BC, and CO plus OA is greater than CA. And so when we add all of these inequalities, we get 2 times AO plus BO plus CO is greater than AB plus BC plus CA. And then we can divide both sides by 2, giving us the inequality which is desired, by which the question asks for, which is AO plus BO plus CO is greater than half AB plus BC plus CA, which is the perimeter of the triangle.
Excellent. Excellent. Very nice. So I would like to just point out to the audience a couple of things. One is this, that Gurnoor actually use LaTeX, isn't it? Is that, it seems like LaTeX to me, right?
Yeah, yes.
Yeah. Okay. So LaTeX is a language, like a typesetting language used by mathematicians to create papers, presentations, and books and stuff like that. So I'm we did not teach her LaTeX in Cheenta. So I'm pretty sure she picked it up herself or learned it somehow, and then she used it in this particular presentation, which is fantastic. The second thing is that she is doing a really good job in clearly stating what she has translated and also discussing the problems from that paper. This is fantastic. I really like this, Gurnoor, that you have not only translated the paper, you have learned the content of it, which is the main purpose of this project at any rate. Okay, please continue. Yeah.
Yeah, sure. So, as you were saying about the latex, I learned that because we also make the math circle questions and the content
Oh,
papers
okay.
in latex. So I learned it with that.
I-
Yeah.
That's great. Okay, please
Yeah.
continue.
So, one really interesting thing that the original author of this paper talks about is that we should try solving a few more problems by proving inequalities on our own. And so, we need to choose triangles wisely, write down the inequalities for their sides, and then transform these inequalities to the desired form. So, we'll not always get what the question asks for right away after writing the triangular inequalities, and so we'll sort of have to play around. Like in the previous question, we had to add the triangular inequalities and then divide both sides by 2. So just kind of perform operations with the triangular inequalities, which will ultimately give us what the question asks for.
Okay. Okay. That's great. Yeah.
So another problem from, which is also from this paper, is that prove that the sum of the diagonals of a convex pentagon is less than twice its perimeter. So what a convex pentagon is, any convex polygon is a polygon whose all angles are less than 180 degrees, and any 2 points lying inside the polygon, so the line joining both of those points will always lie inside the polygon. So here we have a convex pentagon, and so we have to prove that the sum of the diagonals of this convex pentagon is less than twice the perimeter of the convex pentagon. So a pentagon has 5 diagonals, and so here we have a diagram of
Okay.
the
Problem. Yeah.
pentagon A, B, C, D, and E. And so
Mhm.
here the triangular inequality, sorry, the diagonals of this pentagon are P, Q, R, S, and T. And so as you might be able to notice that these diagonals form triangles with the sides of the pentagon. So we have PAE as one triangle, we have QBC as another triangle, we have TED as another triangle, we have SDC as one triangle, and RAB as a triangle. So these are the triangles that we'll be using to help us with this triangular inequality, with solving this problem. And so here we have the solution to this problem, which basically uses triangular inequality to solve the, like, to give us the so uses the diagonals and the sides. So for example, for the triangle PAE, the sides, so we
Okay.
have the
So
triangle
in each of the triangles, you are applying triangular inequality.
yes,
So
yeah,
PQRST, these are the diagonals, and ABCDE, these are the sides.
yes,
Okay.
yeah,
Oh, yeah, I think everyone understands this. I don't think you have to read the entire thing, but we
yeah,
understand that in every triangle we have this thing. That so if you go back to the previous slide once, can you do that? Yeah. So if you look at the triangles, in every triangle, two sides are diagonals, and one side is the side of the pentagon. So in every triangle involving the diagonals, two of them are diagonals and one of them is a side of the triangle. But then you can also have other types of triangles where two sides are side of the pentagon and one side is a diagonal. So you have to use that other kind of triangles to actually solve this problem. Okay,
yeah,
very nice. Yeah. Okay, excellent. So you can proceed to the next slide. Yeah, and the next one.
yeah. So we just add all of these triangular inequalities to give us the desired form for the question asked for.
Very nice. Okay. Okay, that's very nice, Gurnoor. I really appreciate the work that you are doing. You are working on the main program, you're doing the math circles, you're doing these projects. I seriously want to work with you on this because this is the goal. The goal is that Quant, so those of you who are listening to this talk, this is a translation from an article from a very famous Russian journal for high school students. This is known as the Quant. Now, this journal is being published since 1970, and as we all know, Russia has a very good culture of mathematics from a very long time. They have great problems, great discussions, and so on. So, what we would like to do, Gurnoor, is we would like to create a section in Cheenta's website where we will put all of these translations that you are making. Okay, maybe you can build a small team with you with other Cheenta kids, and you can do a few translations every month, help them to do as well, and that will be a very good free resource for other kids who are out there who just want to read some good mathematics. I think
True.
that would be really nice. It would also add value to your resume if you are applying for universities outside India, let's say after high school or something. This can be a very good piece of work that you can also use to further your academic goals. I think
Yeah,
this is fantastic. Yeah.
thank you.
Okay. All right, Gurnoor, it was great having you, and we will stop out here today. But I hope that I'll be able to see you and your friends more in this channel. Take care. Thank you for
So,
coming in.
yeah,
Okay.
thank you so much. Have a good
Sure.
day.